All right, let's get started. Let's stop talking, please. Let's recap quickly. Law of sines. We use law of sines when we have an angle-side-angle triangle or angle-angle-side triangle, and this is when we get one triangle. Those are our two ideal law of sines situations: angle-side-angle or angle-angle-side. If we have side-side-angle, we have our possible ambiguous case. We could get 0, 1, or 2 triangles, depending on the information that we're given. I think it'd be an infinite number. We're going to use today the law of cosines for our two other possibilities, side, angle, side. And we use that when we want to solve for a side. And when we have a side, side, side triangle, we solve for an angle. There are no ambiguous cases for the law of cosines, because we get a unique triangle for side, angle, side, and side, side, side triangles. All right, for side, angle, side. For side, angle, side triangles, law of cosines, I'm going to write 3 different equations. It's really one equation with the letters rearranged. So, and I'll talk about that a little more in just a second. So for side, angle, side triangles, we use that to solve for a side. We get a squared equals b squared plus c squared minus 2bc cosine a. And let me draw, here's our triangle, just as a reminder what we're talking about here. Our sides, our angles, and our sides. B squared equals a squared plus c squared minus 2ac cosine b. And c squared equals a squared plus b squared minus 2ab cosine c.
Well, we haven't memorized this.
Yes.
What? Oh, you're not joking?
Well, let's look at these. What does this look like? C squared equals a squared plus b squared. So what does it kind of look like? Pythagorean theorem. Well, what if C is a 90-degree angle? What if there is a right angle in the triangle? What is cosine C?
90 degrees.
What's a cosine of 90?
0.
0. That goes away. So if there's a 90-degree angle in the triangle, law of cosines becomes the Pythagorean theorem. So the law of cosines is a generalization of the Pythagorean theorem. And it actually comes from using the Pythagorean theorem and a little bit of trigonometry. Just like we did before, we divide this into a right triangle and use the Pythagorean theorem and some trigonometry. Couple of other points about the equations. Whatever side we're interested in, A here, that's the angle. It's on the other side of the equation. On the other side of the equation, only the other two sides are involved. B and C here. Here we have b squared cosine b, and the other sides here are a and c. Here we have c squared, angle c, and then here we have just a's and b's. So what I recommend is remember one of these, whichever one you like. I like this one personally. And then if the triangle is not drawn that way, just relabel your angles and sides so that they match up with the equation that you like. So it's really just one equation. It's not 3 equations. It's one. Just depends on how the sides of your triangle are labeled. All right. If we have a side triangle, and we use law of cosines to solve for an angle, I'm going to write 3 more equations. But what these equations are is just taking this equation and solving for cosine A. Take this equation and solve for cosine B. Take this equation and solve for cosine C. So you don't need to remember another equation. Just remember you can rearrange this, solve for the cosine of the angle. So from the first one, I can say cosine A equals b squared plus c squared minus a squared over 2bc. So I'm just solving this equation for cosine A, getting cosine A by itself. Second equation, I get cosine B equals a squared plus c squared minus b squared over 2ac. And from the third equation, cosine C is a squared plus b squared minus c squared over 2ab. Each of these comes from one of those. So what I recommend, remember one of these, relabel your triangle appropriately, and then just remember you can rearrange that to get your cosine. Yes?
How come it's over 2bc instead of minus 2bc?
So what I do to solve here is I add 2bc cosine A to that side and subtract the a squared.
You can't just divide the cosine a from the...
No.
Okay.
All right, so those are our formulas, our equations. It's really one equation that's rearranged in several different ways. So don't think of it as 6 equations. Think of it as one equation. All right, so what I want to do is go through a couple of examples. And as we go through the examples, I'll point out some information that you want to be careful with law of cosines. Because there's more stuff going on, it's easier to make a mistake with law of cosines than with law of sines. Not a law of tangents. All right, so for the first example, and we're going to learn another area formula today. All right. So we want to find the angles in this triangle. So I'm going to draw a picture first, just like always. And I'm going to say that's 5, that's 8, and that's 7. So this is going to be A, B, and C. We have a side triangle. That tells us law of cosines. Now, I believe that for what we do, it'll always say use law of sines, use law of cosines. But if you're not told which one to use, if you tried to use law of sines here, you'd be missing information. You'd have 2 missing pieces in your equation that you'd set up for law of sines. That would tell you that law of sines is not going to work. When we're trying to solve for an angle, the other piece of advice that I want to give you is solve for the largest angle first. And as we go through the problem, I'll tell you why you want to do that. All right, so which angle is going to be the largest angle?
B.
Angle B. Largest angle is across from the largest side. Medium angle is across from the medium side. Small angle is across from the small side. So I'm going to use the equation. Cosine B equals a squared plus c squared minus b squared. Over 2ac. And I'm going to say that then b is going to be the inverse cosine, and I'm going to plug my numbers in here, of 5 squared plus 7 squared minus 8 squared over 2 times 5 times 7. And you can put this in your calculator. I would recommend probably putting some parentheses there. And I get that B is approximately 81.8 degrees. All right, second piece of advice. When you use the law of cosines once, finish the problem with law of sines. Because law of sines is easier to use, and now we have a side angle side triangle. Or no, sorry, we have a side side angle triangle, and we can use the law of sines on that. So I'm going to say I'll solve for angle A. Sine A over 5 equals a sine of 81.8 over 8. So A is going to be the inverse sine. This is exactly what we did last couple times. Over 8. And I get that A is approximately 38.2. Now the reason, before we finish up, the reason that I say solve for the largest angle first is if we don't solve for the largest angle, but then we use the law of sines to find the largest angle. If that largest angle happens to be obtuse, your calculator, when you use the inverse sine, will not give you an obtuse angle, because the inverse sine is between negative pi over 2 and pi over 2. So it's only going to give you an acute angle as an answer for an inverse sine question. But if we did, because the domain restriction for our cosine function for the inverse cosine is 0 to pi, your calculator will give you an obtuse angle when you use the inverse cosine. So if this angle, if angle B had happened to be obtuse, and then we use the law of sines to solve for that obtuse angle, we would end up with a mistake. We'd get an acute angle instead of an obtuse angle, and our answer would be wrong. All right, and then we can find angle C with subtraction. So we get C is about 60 degrees with how we've rounded this. All right, questions there? So first piece of advice with side triangles, solve for the largest angle first in case it's obtuse. Always for law of cosines, once you use the law of cosines once, finish with the law of sines. You can use law of cosines again, but law of cosines is more complicated than law of sines. I'm right? All right. Next example. Angle C is 111, A is 27, and B is 18. We want to solve the triangle. All right, here's my picture. A is 27 and B is 18. All right, so here we have a side angle side triangle. So that tells us law of cosines. And since we want to find side C first, so I'm going to use C squared equals A squared plus B squared minus 2AB cosine C. And just plug in some numbers here. So C squared is 27 squared plus 18 squared minus 2 times 27 times 18 times the cosine of 111 degrees. All right, first place to be careful with this part of law of cosines is cosine of 111 degrees, positive or negative?
Negative.
Negative. So we have a negative number here times a negative. So we end up adding this quantity. So be careful with that. If you plug it in your calculator like that, you'll be okay. But if you do intermediate calculations, it's easy to forget that this possibly can be negative, and you end up adding. So here we get c squared equals, when I calculate this all out, I get 1404.33. The second place that students sometimes make mistakes with law of cosines is this is c squared, not c. So to find c, we have to then take the square root. So c is about 37.43. All right, and then we're going to finish with the law of sines. You can use the law of cosines again if you would like, but you don't have to. And I'm going to find angle A. So sine A over 27 equals the sine of 111 over 37.43. So A, just like we've done the last couple days, inverse sine of 27 sine 111 over 37.43. So we get A is about 42.3 degrees. And then we can subtract from 180 to get that angle B is 26.7. All right, questions there? You need to remember the law of cosines formula. All right, our area formula. Heron's area formula. Heron was the name. Heron was a Greek mathematician.
Heron's a bird. Bird. You're right.
All right, so I'm going to write the formula up here, and then I'll talk about what the different parts mean. Heron's area formula comes from the law of cosines. So we use Heron's area formula when we have 3 side lengths. So that's all we know about the triangle is 3 side lengths. So before I write the formula, let me talk about how difficult that problem would be without this formula. So we know what's our basic area formula for a triangle? Base times height divided by 2, right? We don't know any of these angles. So what we would have to do to find the area of this thing is find the height. Well, to find the height, we need to have a perpendicular segment from the base of the triangle to point C. So what we would have to do is put our triangle on a coordinate system, write the equations of the lines that represent those 2 sides, find where they intersect to find point C, and then find the equation of the line that's perpendicular to the base of the triangle It goes through point C. And then we'd have to find where that line intersects the base of the triangle and use a distance formula to find the height of the triangle. That's a very involved problem. Well, Heron came up with this method for calculating the area of this triangle. It has to do with the law of cosines. The area is the square root of S times S minus A times S minus B times S minus C, where S is A plus B plus C divided by 2, which is called the semi-perimeter.
When you have too much free time at the end.
Semi-perimeter because it's half the perimeter. So this is the area formula that this Greek mathematician came up with that's based on the law of cosines.
How is it based on the law of cosines?
Because you can use the law of cosines to come up with the piece of information that you need to find the area of the triangle. You substitute that in and simplify, and you get this. All right, so for example, for the area formulas, if you need them on a quiz or a test, I would provide the area formulas. But the main thing I want you to know is that they exist. You have seen them. When we talk about vectors in 3 dimensions, we'll talk about another way of finding areas of triangles. So let's say we know that we have a triangle. With sides 50, 58, and 69 feet. We want the area. So my semi-perimeter is 50 plus 58 plus 69 divided by 2, which is 88.5. And my area is going to be the square root of 88.5 times 88.5 minus 50 times 88.5 minus 58 times 88.5 minus 69. And we calculate that out, and we get that this is about 1423.54 square feet.
Does there need to be a plus or minus in front of it? Oh, just throw those
No.
up. Never mind.
Since it's an area, it's got to be positive.
Are you sure?
I'm sure.
So if we put a negative with it, it's going to be wrong on the test.
Yes, I would take points off.
Would you really?
Yes.
Well, like we got the right answer. Come on.
No, the answer is not negative. That's
So
not
like if we
that's
put
not
a plus
correct.
or a minus, like that little like plus minus thing in front of it, would be wrong.
Yeah, I would take half a point off for that.
Technically, it's right though.
What if we forgot the square, the feet square?
That I might be more lenient on. Yes. I've also seen this formula called Hero's formula. So I think hero is a different spelling or pronunciation. Hmm? No, that's the different pronunciation of the person's name. All right, you good, Sammy?
Yeah.
Okay.
Does that mean that's reasons? Yeah. Yeah. Okay. Yeah. Okay.
All right, there you go.